So we are going to learn the first theorem in our first module. That is this. So here, while writing theorems and all, you have to learn the proof very well, because mainly we need to write the proofs and all in our examination. Okay. So here, if you see, the question is, if G is a graph, okay, graph is given with E edges and N vertices. Okay, V1, V2, like that, N vertices are there. Then I have to prove that the summation, this is summation of all the degrees of each of these vertices 2 times the number of edges. This is what we have to prove. Okay, so our theorem is this: if there is a graph G with E edges and N vertices, we have to prove that the degree of each vertice's sum, if we took, it is basically 2 times the number of edges. So here, if you see, how do we prove that is what we have to consider here. So here, let's see, degree means the number of edges which is there incident to a particular vertex is degree. We know that number of edges which is touching a particular vertex. Now here, if you see, if you have one edge, for one edge you have V1 and V2, 2 vertices is needed. So that means here, if we see, that one edge would has 2 vertices, let's say VA and VB. Let's say VA and VB, that's fine. V and VB. So by the definition, for degree of these, so for if you consider one edge, I'm considering the case of one edge. So one edge has 2 vertices like this. To make a one edge, you have 2 vertices should be needed. So this vertex would have a degree of 1 and this vertex would have a degree of 1, right? The edges which is touching this vertex is 1 and this edges which is touching this vertex is 1. So for one edge you have 2 vertices, okay, one edge. So so that means one edge can contribute 1 plus 1 2 times to the total degree. This we have understood, because here if you see, I hope if you're not understanding, I will explain that again. That is, here if you see, consider one edge. To make one, this is one edge. To make one edge, you require 2 vertices VA and VB, let's say. So if I am finding out the degree of VA, this VA is touching one edge, so it is 1. VB is touching one edge, it is 1. So for the total degree sum, one edge contributes how many times? 2 times, right? One edge contributes 2 to the total degree sum, right? So that means if there are 2 edges, then one edge contribute 2 times, so the other edge also contribute 2 times. So total 2 into 2, 4 times it will contribute. Now if you see 3 edges, if one edge is contributing 2 to the total degree sum, then for 3 edges it will contribute 3 into 2, that is 6 times. That is what we have to prove. That here if you see, first we are writing what degree means. What degree means the number of edges which is incident to a particular vertex. So then we have said each edge connects exactly 2 endpoints. For each edge there will be exactly 2 vertices or 2 endpoints when you're considering the simple graph. Because here we have to understand, we are considering what here simple graphs are what we are going to consider. Okay, simple graph means no parallel edges there, no parallel edge or no loops is there. So such graphs thing we are going to consider here. So that means if you consider any one single edge which is connecting, let's say single edge EK, which is connecting these VA and VB, the 2 exactly. So that means then we will see in our next thing that we are going to say in the proof is that consider an edge EK that is like this, which is VA comma VB, means their endpoints are the end vertices of these edges. Edge EK is VA and VB. So VA would contribute plus 1, that is to the degree of vertex VA, and degree of vertex VB would be plus 1. So that one edge can contribute exactly 2 times to the total degree, right? So that means if I am calculating the total degree of all the vertex, Vi means V1, V2 to all the vertex, that means if how many edges is there, each of these edges 2 times, right? That means 1 plus 1 is, if I am having each edge I will consider. Let's say each edge VA and VB I am considering. Each of these edges would be plus 1 plus 1. Each of one edge would contribute 2 times. So that means if total I have let's say 4 edges, that means 2 plus 2 plus 2 plus 2, because 4 edges means there are 4 edges, right? So 4 edges means one edge means 2 it will give to the degree. So if there are 4, it is 2 plus 2 plus 2. This is nothing but 2 times the number of edges. 2 times 4 is what we are calculating here, right? 2 plus 2 plus 2 plus 2, right? So then we can say that it is nothing but 2 times the number of edges. So the summation, the total degree of the vertex E is 2 times the edges. Here we have proved this theorem, right? So here if you see one example here, in this case you have 3 vertices and there are 3 edges. If there are 3 edges, each of these edges would give 2 times to the total sum. See that you can prove it like this. V1, if you consider V1's degree is what, 1 2, so 2. V2's degree is what, 1 2, so 2. V3's degree is what, 1 2, so 2. Then if we sum all of these degree, we get 2 plus 2 plus 6. This is nothing but 2 times the number of edges, that is 3, that is itself 6, right? This is how we are proving this theorem.